Hello, doctor. My name is Yao Lei Wei. Now, I would like to do a brief introduction for the proposed system in this project. Diabetic mellitus is a long-term health condition that impact millions of people globally. This disorder disrupts normal blood glucose level regulations, primarily caused by either insufficient insulin production, type 1 diabetes, or the body reduced the sensitivity to insulin hormone, which will cause the type 2 diabetes. For the problem statement, current glucose monitoring method require frequent finger prick tests which are often painful and inconvenient. This will lead to poor patients compliance with regular monitoring, and this highlighted the need for non-invasive, accurate, and easy-to-use alternative for glucose monitoring system. In order to address this issue, this project proposed a non-invasive blood glucose monitoring system that utilizes a dual-band microwave sensor integrated with machine learning. To ensure the successful completion of this project within its defined scope, three primary objectives have been outlined. The first objective is to design and develop a dual-band microwave sensor capable of detecting glucose-induced variations in human tissue dielectric property non-invasively. The second objective is to implement a machine learning algorithm for real-time blood glucose concentration predictions by analyzing the microwave sensor data. And the last objective is to evaluate the performance of the integrated system through the experimental testing and clinical comparison with standard blood glucose monitoring method.
Hello, Doctor. Now I explain about the key tasks and the roles of project manager and team members. The first activity is requirement analysis, which is undertaken by project manager and biomedical engineer. Project manager will planning, executing, monitoring, and closing a project, where the biomedical engineer will ensure that the medical device meet the medical standard. The next stage is studying existing technologies, who is undertaken by R&D engineer. The engineer will gather data from journal, patents, and also the case study. The next stage which achieve our objective one is sensor design and prototype, which is undertaken by radio frequency engineer. The engineer will using a dual band pass filter based on the split ring resonator to detect the glucose level in several frequency levels. The next activity is simulation of sensor. This task falls under responsibility of a radio frequency engineer, which using CST Studio Suite to stimulate the dual band microwave sensor and refining the sensor design to enhance the performance. The fifth activity is sensor fabrications, which is undertaken by technician and RF engineer. The technician is responsible for development and assembly of the hardware system, while the radio frequency engineers maintain a high standard of quality and adherence to design specifications. The next activity is sensor integration and packaging. Who is responsible is hardware engineer. Responsible for ensuring the design is physically and electrically integrated into the system and properly protected. The next activity is tissue phantom testing, which is undertaken by lab technicians. We will perform the experimental procedure and gather the data for analysis. Next is data pre-processing. This task falls under the responsibility of machine learning engineer. He or she will pre-process the data, such as noise removal and normalization to ensure the accuracy and ready for the model training. Next is the feature extraction, which is undertaken by machine learning engineers. He or she will identify the feature to optimize the predictive performance. The next step that achieves our objective 2 is machine learning model development and training, which is carried out by the machine learning engineer. The engineer will select the appropriate models to train, such as support vector machines, artificial neural network, and others, to recognize the pattern in sensor data that correspond to know the glucose level. The next stage involved is model validation and evaluations, which carried out by the machine learning engineer. The engineer will verify the model accuracy on new and unseen dataset. The system integration and implementations are the responsibilities of the embedded engineer and software developer. The embedded engineer will integrate all system components to enable real-time operations, while the software developer will design and implement a user interface to display the glucose level. Next is clinical testing and performance analysis. It is to achieve our objective 3 and is conducted by the radio frequency engineer and also project manager. Radio frequency engineer will analyze and compare the sensitivity and accuracy of the dual band microwave sensor with standard glucose meter by using the Python and MATLAB. Where the project manager is responsibilities in final report preparation and oversight. The subsequent step is data management and storage, which is carried out by data manager. The data manager will organizing, securing, storage, and maintaining the project data throughout its life cycle. Where the last activity is system security, which is performed by the cyber security specialist. Cyber security specialist will protecting the system against cyber threats and ensuring that the data and system integrity.
Good day, doctor. Now I'm going to discuss about AON network diagram. It helps to visualize project tasks, order, dependencies to plan schedule effectively. It also identifies the critical path showing which tasks must finish on the times to avoid delay in the project. This is our project AON network diagram. As the bottom left showing that each of the numbering in the small square represent of each of the terms. Now I'm going to discuss about the forward parse. Early starts equals to the maximum EF, while the early finish equals to the ES plus D. So now I'm going to take activity D as an example. As activity D ES equals to 7. This is because the CEF is bigger than the BEF, while the EF for activity D is equals to the 7 plus 3 will be equals to 10. While backward pass late finish equals to the minimum LS, late starts equals to the LF minus durations. I'm going to take I activity as an example. As ILF equals to 28, this is because J has the smallest LS compared with N. Well, ILS equals to the 28 minus 4 durations, hence it will becomes 24 SLS. Critical path is a sequence of activity where slack equals to 0, also known as the minimum project durations. In these projects, there are two possible critical paths, which is path 1 A, C, D, F, G, H, I, J, K, M, and path 2 A, C, E, F, G, H, I, J, K, M, which both have 43 days. Even though both paths takes 43 days, path 1 is prioritized because D directly impacts the successor's task without flexibility, while E has the slight scheduling leeway. This ensures the most rigid timeline is followed for on-time project completions.
Now I would like to discuss about the financial resources and budget estimations for the one-year system development. The purpose of budget estimation is to provide a clear financial plan to ensure that all aspects of the project, from the labor personnel to equipment and testing, are properly funded. It also helps in resource planning, cost control, and stakeholder confidence. Our project budget covers five main categories. The first category is the personnel cost, which cover the salary for the engineer, project manager, developer, and the supportive staff over the 12 months. The second category is the equipment and hardware. It covers the tools and devices that needed for sensor development, signal testing, and prototyping. The third category is the software and licensing. It includes the purchase of simulations and machine learning software license. The fourth category is the testing and clinical validations. It covers the expenses for ethical approval, clinical trial, and volunteer compensation. And the last category is the miscellaneous and overheads. It covers the travel, documentations, and the contingency buffer to cover the unforeseen costs. The total budget estimations cost for the complete development and validations of the system is 1,301,626 ringgit and 84 cents only. This will ensure the project can be completed effectively, on time, and within the scope. Accurate budgeting helps to prevent the financial overrun, ensure the project feasibility, and provide a realistic outlook for stakeholder and the investor.